Hello everyone, this is Lian Marie Barangco of PSEC3C, and for EC23 or Communications 2, we're going to discuss about MCCDMA in this video. Multi-Carrier Code Division Multiple Access or MCCDMA is a relatively new concept. Its development aimed at improved performance over multipath links. From CDMA, that means one channel carries all the transmission of data simultaneously in a shared media with no collision. So MCCDMA actually means that this modulation method uses multi-carrier transmission, and this functions to allow the system in supporting multiple users at the same time over the same frequency band. So it is frequency-based or in frequency domain. Also, this is used in OFDM-based telecommunication system as a multiple access scheme. And next is, this was proposed by Leonard C. and Fitwise in Yokohama, year 1993. So that's a little history about MCCDMA. And they show that MCCDMA signals can be detected with a simple receiver structure using fast frequency transform and a variable gain diversity combiner. So there are many definitions or many ways that we can describe MCCDMA, and for example, these are MCCDMA as a form of CDMA or spread spectrum, but we apply the spreading in frequency domain rather in the time domain, because in the time domain we use the direct sequence CDMA. Another one is as a form of direct sequence CDMA, but after spreading, a Fourier transform or fast frequency transform is performed. Next is as a form of orthogonal frequency division multiplexing or OFDM, but we first apply an orthogonal matrix operation. But first, we apply an orthogonal matrix operation to the user bits. Another one is a form of direct sequence CDMA, but our code sequence is the Fourier transform of a Walsh-Hadamard sequence. And lastly, as a form of frequency diversity, where each bit is transmitted simultaneously in parallel or many different subcarriers. So this subcarriers has a constant phase effect offset in the set of frequency offsets from a code to distinguish different users. So first is the application of MCCDMA as a possible transmitter implementation. In here we have input, which is represented by AIK, where AIK is the transmitted signal in the form of amplitude and its spectrum. And we also have C sub IO, C sub I1, and C sub I n minus 1, where these are called the subcarriers. So these subcarriers has transmitted bits that is imposed on the carrier, which is implemented in these formulas, where C sub IO is, or C sub I0 is represented by cosine 2 pi FCT, and C sub I1 is represented by cosine 2 pi FC plus F over TB times T. And lastly, as C sub I n minus 1 is cosine 2 pi FC plus n minus 1 F over TB times T. And it is going to be inputted in our summation, summation symbol that is equivalent to the transmitted signal due to the implementation of multi-carrier spread spectrum transmitter. So, in this transmitter implementation, TB is represented by the time duration and N is the number of subcarriers. Next is the implementation using the inverse FFT encode matrix. So, MCCDMA systems allow simultaneous transmission of several such user signals on the same set of subcarriers. In the downlink multiplexer, this can be implemented in inverse fast frequency transform and a code matrix. So we have here user signals which has multiple inputs that is going to be conveyed in the Walsh-Hadamard code matrix and is going to be soon transmitted into the inverse fast frequency transform and is going to be converted from parallel to serial, and the final output or the data is going to be sent into our transmitting antenna. Next is the MCCDMA as a special case of DSCDMA. So first we have here a single input user signal that is going to be converted from serial to parallel. So as a serial input, we have only a single input. And when it is transmitted to parallel, we have multiple outputs from the given input. Now, this is going to be sent to the Walsh-Hadamard code vector, given with its equivalent data. Next would be transmitted to our inverse fast frequency transform, and the data will be converted from parallel to serial. So another one output is going to be transmitted to our transmitting antenna. So this MCCDMA as a special case of DSCDMA is a transmitter that can also be implemented as a DSCDMA transmitter, which the user signal is multiplied by the fast code sequence. However, the new code sequence in the discrete Fourier transform of a binary will be a Walsh-Hadamard code sequence, so the future values will be complex. Next is the alternative implementation of MC spread spectrum. So we have here the Walsh-Hadamard code vector with its equivalent values that is going to be transmitted in our inverse fast frequency transform, converted from parallel to serial data, and the output is going to be combined with our user signal, and the answer or the final product is going to be transmitted to the transmitting antenna. Next is the receiver design model. So back to our first diagram, we have the transmitter implementation, which we can assume is the sender or the transmitted implementation as a sender that is going to be received by this model or design. So we have this receiver design model for the reason of the delay spread and frequency dispersion due to multipath fading. And subcarriers are received with different amplitudes. So if there is an error from the sent data, this receiver design model is going to create or find a solution from the discrepancies that are being sent. So an important aspect of the receiver design is how to treat the individual carriers depending on their amplitude. And the options are, it can be the solution of finding the linear combining or using linear combining by using maximum ratio combining, the equal gain, the using of equalization, or the winner filtering, and the maximum likelihood detection. So that is just one of the functions or choices in that is used in this receiver design model. So when we have the received input or received data, it is going to be applied in these subcarriers that is implemented bits that is imposed from the previous carrier. So this is the transmitted bits already with this given formulas, and it is going to be sent into this summation sign that represents the transmitted signal due to the implementation of multi-carrier spread spectrum transmitter, and it is going to be sent to our integrated circuit or IC. What are the advantages of MCCDMA? So compared to direct sequence or DSCDMA, that is a method to share spectrum among multiple simultaneous users. MCCDMA is better because in DSCDMA, it can exploit frequency diversity using the rate receiver. And in this dispersive multipath channel, the CDMA with a spread factor n can accumulate or accommodate n simultaneous users only if highly complex interference cancellation techniques are used. And in practice, this is difficult to implement. So MCCDMA can handle n simultaneous users with good bit error rate using standard receiver techniques. So MCCDMA is better than DSCDMA because it can deal with bit errors in the minimal. Next is MCCDMA that has optimal use of encoding by using matrix operation compared to OFDM. So it is used to avoid excessive bit errors on subcarriers that are in deep fade because OFDM typically applies coding. So the number of the subcarriers that is needed is larger than the number of bits or symbols transmitted simultaneously. So as a solution, which makes MCCDMA better, it replaces this encoder by an n by n matrix operation. So the initial results reveal as an improved bit error rate. So these are the references that I made in researching about this topic. Thank you.